Hey guys, welcome to our next lesson, lesson 11.2, and this lesson is going to focus on rational expressions and functions. And so of course the very first thing that we're going to do is define what a rational expression is. So a rational expression is absolutely anything that can be written as a fraction. So when you see this word rational, and this is going to show up all over the places. You guys go through high school math and into college, you'll see it on the SAT. That word rational, just think of it as synonymous with fraction. Okay? It's a fancy math word, but just in your mind, associate that with fraction. Rational just means a fraction. So a rational expression is anything that can be written as a fraction. Here we have some examples. The first one is 0.3 repeating. This needs to be a repeating decimal that you guys are familiar with at this point. 0.3 repeating can be written as 1/3. That's just one of our extremely common repeating fractions and decimals. So you guys need to know how to go back and forth between the decimal and the fraction. And then our second example, the number 8. Any whole number is rational because you can always make a whole number into a fraction by putting it over 1. Okay, 8 over 1. If you had the number 2, you could put 2 over 1. Notice we also have some non-examples. The square root of 2 is not rational because if I do the square root of 2, I end up with 1.414213562, and it keeps going without a pattern. Okay, so that's why this is not a rational number. There is no pattern and it doesn't end. So that's the difference. 0.3 repeating has a pattern. That's why I can write it as a fraction in 1/3. The square root of 2 has no pattern and it doesn't end. That's why I cannot write it as a fraction. Same thing with our symbol here. We should be familiar with our symbol for pi. Okay? And most people are more familiar with pi being a non-rational number because pi is 3.141592654, and again, it keeps going. But what happens to pi as well? There is no pattern and it doesn't end. So when we have special decimals like that have no patterns and don't end, those are irrational expressions, okay, because we cannot write them as fractions. Now, we're going to focus on rationals for today, but there's a few examples of what you'll be working with in the future. When we're talking about rational expressions, the domain is going to be very important. And remember, usually when we talk about domain, we also talk about range, but domain represents the letter X. When you have an ordered pair, there is always an X and a Y, so the domain represents the letter X. Range would represent the letter Y. But again, the focus for today is going to be domain. Now, the denominator, or the bottom of a fraction, can never be 0. It's not allowed to be 0, right? The top is allowed, because I could give you 0 out of 3 cookies. If I have 3 cookies, I could choose to eat them all and give you 0, okay? But I cannot give you 5 out of 0 cookies. If I have 0 cookies, it's impossible for me to give you 5, okay? So the denominator of a fraction is never allowed to be 0. The numerator is, okay? If the denominator is 0, then we say the expression is undefined. Very important math word because you'll see that a lot moving forward as well. All right, so if 0 happens to be in the denominator in the bottom of the fraction, we say that that fraction or that expression is undefined. So let's talk about finding the domain. Since the bottom can never be 0, you set the denominator not equal to 0. This symbol represents not equal to. That's why you guys see that equal sign with the slash through it. Okay? So that symbol means not equal to. So the first thing we do to solve for the domain is we set the denominator not equal to 0. Then we just solve for x. This is where factoring from chapter 9, factoring from chapter 10 will come in, square rooting from chapter 10 will come in. Okay, so everything really is building from those chapters we've been working on. But that's it. Those are the 2 steps for finding domain. All right, so here's our first example. What is the domain of the rational function? Remember, for domain, I could care less about the numerator. I do not care about the top of the fraction. All I do is I take the denominator and I set it not equal to 0. Then I solve. Is there anything to solve here? No. So this is my answer. What is the domain of the function? X cannot be 0. So what we're saying is x could be any other number. You could plug in 2, you could plug in -16, you could plug in 157. So you can plug in any number that you want, but you cannot plug in 0. So that's what you would tell me. X cannot be 0. That is the answer to this problem. All right, let's look at another problem. For what values is the rational expression undefined? Again, you're going to see this terminology. You have to know what the question is asking you. That's part of the problem. Okay, guys? Knowing what the question is asking you. So when is it undefined? Undefined is when the denominator cannot be 0. So that's what I'm going to do. In example B here, I do not care about the numerator at all. So I just take my denominator and I set it not equal to 0 and I solve. Plus 2 plus 2. So x cannot be 2. So this would be my answer for example B. For what value is the rational expression undefined? For 2. So we are saying that x cannot be 2. X could be anything else, but you cannot have 2. All right? Now let's look at example C. Again, I do not care about the numerator, guys. Literally cross it out. We don't care at all when talking about domain or expressions being undefined. But I'm going to take this entire denominator and set it not equal to 0. M squared minus 5m plus 6 cannot equal 0. This is where it does get a little bit trickier, because how are we going to solve this? Okay, you have to think back to chapter 10, chapter 9. We are going to work backwards. I need 2 numbers that add up to -5 and that multiply to 6. So my 2 numbers are going to be m minus 2, m minus 3. Okay, -2 times -3 is +6, and -2 plus -3 is -5. So now I set each factor not equal to 0. M minus 2 cannot be 0. M minus 3 cannot be 0. I add 2, add 2. So my first answer, for example C, is that m cannot be 2. So there's my first answer. Notice I'm going to have 2 answers. On the right, I add 3, add 3. My second answer is that m cannot be 3. Okay? So example C actually has 2 questions. When is the rational, or 2 answers. When is the rational expression undefined? It is undefined if m equals 3 and if m equals 2. So that's why m cannot be 2, m cannot be 3. Okay, guys? So there are some slightly more difficult versions of dealing with undefined expressions. All right, now let's look at what we mean when the directions tell us to evaluate. Again, terms that you're going to see throughout your math career that you'll see on the SAT, on the college entrance exams. So what does it mean when the directions tell us to evaluate an expression for x equals 3? And here's an example. Evaluate the rational expression for x equals 3, write undefined if appropriate. When we say evaluate, all that means, guys, is plug in. So if the directions say to evaluate for x equals 3, that just means plug in the number 3 for the variable. Okay, so let's do that here for the example. So for example A, we would just have 3 squared, because here where you see the variable, you're going to put 3 minus 4 over 3 minus 2. Because again, here where we see the variable, I'm going to put 3. So what I end up with is 9 minus 4, which gives me 5, and 3 minus 2, which gives me 1. So your answer would be 5 over 1, or just the whole number 5. So if you're asked to evaluate the expression for x equals 3, there's your answer, 5. Okay? Now let's go to example B. Again, everywhere that I see a variable, I'm going to put in 3. So I'm going to have 3 plus 2 over 3 squared minus 5 times 3 plus 6. Okay? And that ends up giving me 5 over 9 minus 15 plus 6. And what does 9 minus 15 plus 6 gives me? 5 over 0. And what's the problem? I can never have 0 in the denominator. So your final answer for B would be that when you plug it in, when you evaluate, your final answer would be undefined. Okay, because when you plug in, it does not work. You cannot have 0 in the denominator. Okay, guys? So my answer for example A would be 5. My answer for example B would be undefined. Now let's talk about our last piece here in the notes is simplifying rationals. Now if a fraction, because remember a rational is just a fancy word for fraction. So if a fraction has a plus or a minus in the numerator, remember the numerator is the top of the fraction. So if there's a plus or a minus, what we do is we break it apart, keep the same denominator, and simplify each part. Seems pretty straightforward, but let's go through some examples here. All right, simplify the rational expression. So, step 1 is to break them apart. So here in example A, I'm going to break apart my numerator. So I'm going to put x over plus 7 over. Remember step 2 is to keep the denominator. So I'm going to keep that 14. So x over 14 plus 7 over 14. Do you see how I have the same expression? I've just broken it up. Now step 3 is just to simplify. So let's go ahead and simplify. X over 14, I can't simplify at all, but 7 over 14 I can. I can divide both of them by 7, and so I end up with a simplified 1/2. So my final answer for example A would be y equals x over 14 plus 1/2. So this would be my final simplified version for example A. Okay, now let's go to example B. Notice there is no plus or minus. Okay, so if there's no plus or minus, there's really nothing for me to break apart. All we're going to do is simplify the fraction. A regular 2/6 fraction. What can I divide them both by? 2. And I end up with 1 over 3. The x is going to stay right where it was in the numerator. So my final answer would be 1x over 3. Okay? All I did there was simplify. There was no plus or minus, so there was nothing to break apart. It was just putting your fraction in lowest terms. All right, guys? And that is it for lesson 11-2. Okay? Your worksheet is already in Google Classroom. Please make sure, this is the whole goal of this lesson. Everything has to be simplified. Okay? If it's not simplified, then your answer is incorrect. This is what your homework will look like. You will have a little bit of review here at the beginning, okay, because this is so important for you to know. Notice you'll have to use a little GCF to solve, a little working backwards. Number 1 is just solving normally. Don't overthink it. Just add 15 to both sides and then divide by 4, okay? So for number 2, you'll have 2 answers. You'll tell me C equals. For 4, you'll have 2 answers, A equals. For number 3, you'll have 2 answers, M equals. But for number 1, you'll just have 1 answer, just Y equals. Okay? For the section down here in the lesson quiz, When is it undefined? Remember, whenever we're talking about undefined, it's when the denominator cannot be 0. So in all of these, you literally don't care about the numerator. You can cross them out if you want to, okay? The numerator does not matter for these. You just take that denominator and set it not equal to 0. X plus 1 cannot be 0, and then we solve. All right? For the last part of the homework, okay, down here, number 6 through 12, notice 6 through 9 has you evaluating for x equals 2 and x equals 1. So that means you're going to have 2 answers. Okay, guys? If you are told to evaluate for x equals 2 and x equals -1, then give me 2 answers. The first set of answers, plug in 2. For my second set of answers, plug in -1. Okay? So you'll have one answer, a second answer, one answer, a second answer. So all of these will have 2 answers. And then for my last chunk of questions here, 10, 11, and 12, you're just simplifying. This is the last example that we just did. Okay, you're going to break apart the fraction. So x minus 6, keep the denominator, so over 12, and then just simplify from there. All right, guys, so that is your homework. Make sure you submit that on time in Google Classroom. And if you have any questions, put those in the comments. Make sure they're public comments so that I can help you out and hopefully help some of your friends out as well when I answer the question. All right, guys? So thank you all for joining me for this lesson, and I will see you for the next one.